All right, grade 12. So this is a basic introduction lesson to a typical design and measurement problem. In this unit, okay, I just want to draw your attention to the learning outcomes. You are basically using your knowledge of design and measurements from grade 10, Introduction to Applied and Pre-Cal, where you calculated the surface area of 2D shapes and you calculated the volume of objects, okay? You're going to be taking your knowledge of that with those formulas that are attached to all of those calculations and applying it to a scenario where you basically have to solve a cost and design problem. So basically, what's going on here is that you're going to have different scenarios where you're going to have to use your knowledge of the surface area calculations, the volume calculations, and then applying it to a budget. But you are going to have to be reading the questions carefully because there's always going to be a context. There's going to be some kind of context that's involved, and so you do have to read those questions carefully. It's not a big unit. We're only going to be doing this until Thursday, okay? So all we're going to do this week is kind of go through different kind of examples, and there will be a bit of an assessment at the end. However, a couple things to help you here. Number one, you need to know the formulas, okay, of the different shapes, the perimeter area, surface area, and volume, okay? So you need to be aware of that. Another thing that's very important is that when you're dealing with pi, okay, you're going to use the pi button, not 3.14, okay? So do not use 3.14, use the pi button on your calculator. All right, there will be some unit conversions that you're gonna have to do, okay? So you wanna be careful with that, but you can use a converter app for it. And when you're dealing with a budget, you wanna be within your budget. So whether it's a minimum or a maximum, okay, you want to be within your you want to be within the budgetary range, and of course don't forget taxes. So again, GST is 5%, and in Manitoba PST is 7%. So don't forget to do the proper tax calculation. So here, just pulled out from the formula sheet the typical calculations for the different shapes, the surface area, and the volume calculation, okay? So you need to know these formulas, be able to be comfortable using them. I want to draw your attention specifically here. You're not always going to be using the whole formula. Again, it's based on the context. So for example, if you were dealing with a can and you needed to know how much metal you needed for the lids, well, you wouldn't care about the sides of the can, okay, because you're not putting the lids on there. You wanted two circular lids, so you'd only use, okay, that part of the formula. All right, so sometimes you're going to be required, all right, if you want the lid on the top and the lid on the bottom, all right, you'd be required just to use a portion of the formula. So again, it's going to be based on the context of the problem. Okay, so let's begin. Let's take a look at this typical example. All right, this one is a pretty straightforward one. It's just solving a problem. We're not actually designing anything. If you look at provincial exams in the past, you see a whole wide range of questions. You get questions like this, where you're just solving a problem, or one of your homework questions is a question like this, where you're actually designing an object. So designing something with a cost and all that kind of stuff. So for our example today, we're going to go through just where we're solving a typical type of a problem. So let's begin. A farmer is selling a cone-shaped pile of grain. Okay, so that's very important, the shape, cone-shaped. All right, so the grain is, well, it's terrible drawing, is in the shape of a cone. I'm just going to erase that. It's a little bit ridiculous. Let's try that again. Shape is we go. That's a bit better. Okay, it's the shape of a cone. So the cone has a diameter, and you're given the height. So the diameter of the cone is 30 feet. And the height of the cone is 20 feet. Now, diameter is twice the radius. If we have a circle, that's our diameter. Okay, radius, twice the radius is the diameter. So we need to know the radius. So radius is diameter over 2. So in this case, the radius will be 30 over 2, which is 15 feet. So we have our height, 20 feet, and we have our radius of 15 feet. So that's important. The grain box of the farmer's truck has a volume of 850 cubic feet. So basically what's happening is that this grain truck shows up and they fill it with grain, and they can hold a maximum of 850 cubic feet. Now that's assuming that they don't make a big pile above the top of the trailer of the truck. Okay, so if I just draw like the typical truck trailer would be like this rectangle, and you're basically going to fill it, okay, with grain there. You're not going to go above. So it's going to basically be the volume, okay, in the truck is 850 cubic feet. Okay, so we have to figure out the volume of the pile of grain, okay? And we are then going to figure out how many truckloads, okay, it will take to transport the grain to market. And now it's asking for the minimum, okay? So if we get a decimal answer, say it's like 10.4, then we're gonna have to make an 11th trip, because after 10 trips, there's still 0.4 of a pile, okay? So we do have to make sure that we round up in a scenario like this. So the first thing we're gonna do is solve the volume of the pile, okay? So the volume of the pile, it's a cone shape. So we go back to our formula, we need the volume of a cone. So it's 1/3 pi r squared h, or we can just go pi r squared h divided by 3. So the volume of the pile will be pi r squared h divided by 3. So we'll leave pi as pi. R is 15 feet. So 15 feet squared times the height, which was 20 feet. And then we'll divide that by 3. So pi times 15 squared times 20, and then we'll divide that by 3, and the volume of the pile is 4,712.38898. So we're going to take all those decimals, okay? So 4,047.12. And I'm having an issue here with my pen. So 712.38898 cubic feet. Okay. Now, the volume of the truck is 850 cubic feet. Technical difficulties here. Bear with me. Okay. So To get the number of truckloads then, will equal the volume of the pile divided by volume of the truck box, I guess you'd say. Okay, good. So then that will equal 4712.38898 cubic feet divided by 850 cubic feet. So 4712, divide that by 850, and you get 5.543987. So 5.543987. Okay, and we have to round up, so that would be 6 truckloads required. So if we go back to the problem, what it's asking here, how many times must the farmer go to market? Our final answer the farmer needs to take 6 trips to market. That will be your final answer. So we round the 5.54 up to 6 because there will still be half of the truckload left, and we can't leave that there because it's money that's required for the farmer to make his living or her living. So hopefully that made sense. We did the volume of the cone, and then we found the ratio to get the number of truckloads. So the volume of the pile divided by the volume of the truck box, and that gave us the number of truckloads. Okay. So how much money is this farmer going to make? The grain is sold by the whole bushel. So a bushel is just a unit of measurement that grain is sold in. The grain has a value of $8.50 per bushel. So each bushel of grain, okay, if that's a bushel, then that would equal $8.50. Okay. It's not working out here. Okay, so we want to find out how much this is going to be worth. So if 1 bushel is equal to 1.24 cubic feet, what's the volume? What's the value of the pile of grain? So again, the volume of our pile is 4,000. What was it again? 4,712.38898. 4712.38898 cubic feet. We want to find that in bushels. The volume of 1 bushel is 1.24 cubic feet. So the way we do this is we are going to then, the volume of grain in bushels will equal the 4712.38898 And we'll divide that, convert it to bushels by 1.24. And we'll get the number of bushels. 4712.38898 divided by 1.24 gives us 3,800.313694 bushels. 3,800.313694 bushels. Good. So we have that. It's asking us now, what's the value if 1 bushel is $8.50? The value will equal $8.50 multiplied by the number of bushels, so 3,800.31364, and we'll get our final answer. So we take our number of bushels, 3,800, and multiply that by $8.50, and you get $32,302.67. So 32,302.67 would be the volume, the value, okay, of our grain pile. So hopefully that kind of makes sense, grade 12s. Typical question here, again, review. Finding the volume here of the grain, okay, and then figuring out how many truckloads it takes, okay, full truckloads. So, or sorry, how many truck trips it would take, be based on the number of truckloads you get, and we round it up because we can't leave a portion behind because we want to sell it to make money. Here we had the volume of the grain pile in cubic feet. We had to convert it to bushels. The conversion was given. 1 bushel is 1.24 cubic feet. So we divided by 1.24 to get the number of bushels, and then we times that by the value of grain per bushel to get a final number of $32,302.67. So hopefully that gives you an introduction to what's going on with our design and measurement, okay? And these 2 questions are for homework. So I'll be giving you the answers tomorrow. But here, this is very similar to the one with the dog in your design and measurement package, but now you have a goat. So what's the area of the barn, outside the barn, that the goat can travel in? And I'm sure you notice that the goat, the maximum, it would kind of be making a circle, right? So that kind of thing there. So, but of course that's 50 feet and that's 40. So there's going to be some overlap here, what they're going to be able to do. So something like that, and that might help you. So do you want to find out what that total area is? Second question I'd like you to work on. This is a typical design problem. Okay, so you're designing a souvenir beach ball according to the following information. So the volume must be between 1 and 3 cubic feet. So you have a minimum volume and a max. So you can pick any number you want between those. It can't be less than 1. It can't be greater than 3. And you have to go through the problem and figure out the minimum selling price for your beach volleyball. So I hope this kind of makes sense, and good luck with these problems today. And if you have any questions, don't hesitate to email me. Have a great day, grade 12s.